Hello and welcome again as we look at yet another multiple choice question for IB Chemistry. Which solution is basic at 25 degrees Celsius? And here you have this equation Kw, the ionic product for water at 25 degrees Celsius, equals 1.0 by 10 to the negative 14. And you've got these four choices. Now, most students are comfortable with the fact that the pH scale runs from 0 to 14, with 7 being neutral. This part of the scale here is basic, and this part here is... But the difficulty with this question is you need to apply some specific equations, and you need to do the calculations mentally, because a calculator is not allowed in paper 1, the multiple choice exam for IB Chemistry. So, given this fact, what you need to know is that Kw, the ionic product of water, is made up of the product of the H3O positive, or it could be written as H positive, H3O positive ion solution, multiplied by the OH minus ion solution. And then that comes to 1.0 by 10 to the negative 14. But what is it made up of? It's made up of 1.0 by 10 to the negative 7 for this H3O positive, and then it's made up of another 1.0 by 10 to the negative 7 for this OH minus. And the product of this, you add these indices and you get 1.0 by 10 to the minus 14. With that information in mind, that the concentration of hydrogen ions or hydronium ions multiplied by hydroxide gives you the ionic product for water. And that is why the pH of pure water at 25 degrees Celsius is going to be based on the negative log to the base 10 of the hydronium ion concentration, or the H plus concentration. It amounts to the same. And if this is 10 to the negative 7, then mentally you should know that this is going to give a pH of 7. So if we had to then find the POH, which is the negative log to the base 10 of the hydroxide ion concentration, then that too would be equal to 7. So the pH of pure water at 25 degrees Celsius is 7. And students are familiar with that. The fact that pH plus POH equals 14. How do you bring all of that information to solve this question? Well, let's look at each answer. Here in A, it says the hydrogen ion concentration is equal to 1.0 by 10 to the minus 3. Now mentally, you need to know that once this is minus 3, that the negative log to the base 10 of that hydrogen ion concentration, it's going to be equal to 3. So this pH is acidic. A cannot be your answer. Then, OH minus concentration here, it's 1.0 by 10 to the negative 13. So then, based on this relationship, where this product always equals 10 to the negative 14, if the hydroxide ion now becomes negative 13, then mentally you should know that the hydrogen or the hydronium would be negative 1, because the product always has to be 1.0 by 10 to the negative 14. So effectively here, the pH is going to be the negative log to the base 10 of the hydrogen ion concentration, which happens to be 1.0 by 10 to the negative 1. So then that would give you a pH of 1 for this. And a pH of 1 is definitely not basic. It's very acidic. So then this cannot be your answer. A solution of pH 4, straightforward. That's on the acid side of the pH scale. So by elimination, we have arrived at the answer of D. But let's see why D is correct. And here now you have the hydronium ion concentration is very small, 1.0 by 10 to the negative 13. So plugging that in here, it means then that the hydroxide ion would be the one that's a lot higher, negative 1. And then this would give a value for pH, the negative log to the base 10 of the hydrogen ion or the hydronium ion concentration. Negative 13, the pH would be 13. And with a pH of 13, That's very much up on the basic side of the pH scale. So then we can confirm that the answer to this question is D.